Compressor is a device which is used to increase the pressure of air from low pressure to high pressure by using some external energy. So using electrical energy we can increase the pressure of the fluid, any fluid. So it is by first law of thermodynamics that energy can be converted from one form to another. So here the electrical energy is converted to the pressure energy, you can say pressure energy of the fluid. So here there are some examples or applications why we need compressed air. For filling the air in tube of vehicles, in automobile service station to clean vehicles, for spray painting in paint industries, in vehicle to operate air brakes, for cleaning workshop machines, for supercharging of an IC engines, for operation of pneumatic tools, that is drills and rock drills and vibrators, etc. Now compressors can be broadly classified into two, that is one is intermittent flow or positive displacement flow. So you know that what is PD. The flow is allowed to flow in only one direction. You cannot close the delivery valve. You know that. Now continuous flow. Now in this PD there are rotary and reciprocating type, and in that rotary type there are sliding vane, liquid piston, helical, lobe, screw, etc. And in reciprocating, which is the main subject of the day, it is called as mechanical piston there. Here you can see rotary is also rotating type of compressor, and continuous flow dynamic is also a rotating type of compressor. And here in the dynamic type of compressor the speed of the rotation is very high, and depending on the flow, how the flow happens inside the veins or on the veins, it is classified as radial or centrifugal and mixed and axial type of compressors. Now ejectors, I can show it in the figure here, the third figure you can see here. So using the highly compressed fluid, you can compress a lower pressure fluid. So this fluid is coming in, and here there is a compressor fluid, so you're not going deep into it. And here you can see a rotary screw compressor, and you can see what are the advantages here, just read it. And the reciprocating type of compressor is here, and it has got some advantages like low mass flow rate, service life longer, high pressure ratios, bigger size, and is relatively cheap. Now here it is a centrifugal type of compressor which is used in a jet engine, and cutaway portion is given here to compress the air that is coming into the combustion chamber. Now there are some definitions for compressor. Compression ratio is defined as the ratio of volume of air before compression to the volume of air after compression, and obviously this compression ratio will be more than 1, since the air before compression will be having a higher volume. Then compressor capacity, which is expressed in meter cube per minute or meter cube per second, it is the quantity of air actually delivered by the compressor. And free air delivered, it is the volume of air delivered by the compressor under the compressor intake conditions. Basically intake conditions will be the ambient temperature and pressure. Mostly it will be ambient temperature and pressure, and we will discuss about it in the last portion of the chapter. And swept volume, the volume displaced or swept by piston which it moves between top dead center and bottom dead center. It is simply the volume through which the piston is moving, that is simply the swept volume. Fine. And clearance volume, it is the difference, better to say like this, clearance volume is the volume which is on the upper part of the combustion, not combustion chamber, upper part of the cylinder, where the walls are all kept. So we cannot make it completely zero, and there will be some volume left behind before compressing the before moving into the collecting tank, and that is the clearance volume. Now this clearance volume plus the swept volume is total volume. Now you can simply say that this clearance volume is total volume minus the swept volume. We will see what is volumetric efficiency. It is the ratio of actual volume of the free air delivered at standard atmospheric condition in one delivery stroke to the swept volume by the piston during the stroke. So while when the cylinder is coming or sucking in the air, uh, theoretically it is the swept volume. It's the volume of air that is coming into the cylinder will should be swept volume. So it shows simply the volumetric efficiency. And if that much volume of air is coming in, then it means it has got 100% of volumetric efficiency. And if it is lesser than that, then the efficiency is lesser. So it shows the breathing capacity of the compressor. Now, isothermal efficiency, it is defined as the ratio of isothermal power that is required input power at isothermal process done to the indicated power or actual work done. So we have three approximations how the process happens, compression process happens. One is isothermal, and second one is polytropic process, and other one is reversible adiabatic process. So in that, if we consider the process to be isothermal process, then it will consume some power. So if you consider that power, and if we take the ratio of that power to the indicated power is the power that is given to the fluid by the piston. Fine, that is the power that is taken by the fluid, that is the indicated power. Fine. Now mechanical efficiency, it is the ratio of indicated power to the shaft power. So what happens here, when we put in electrical energy, it is converted to it is converted to the mechanical power of the compressor. So in between that there will be some losses, obviously some losses. And here also the shaft power, so electrical energy in the electrical motor also there will be some losses. And if the electrical energy minus that losses will be the shaft power, and shaft power is given to the compressor. That means the here it is the piston. So that if whatever power that is given by the piston to the fluid, that is the indicated power here. And the ratio of indicated power to the shaft power, because obviously there will be some losses while the shaft power is converted to indicated power. So considering that, there we can define an efficiency which is called as mechanical efficiency. Now overall efficiency is the ratio of isothermal power to the shaft power.